In this video, we are going to look at finding the inverse of a linear function. Now, you are able to find the inverse of lots of other functions. It's just that in this particular video, we are going to focus only on linear functions. Okay, so let's remind ourselves, what makes something linear? Well, what makes it linear is that when you graph it, it makes a line. I have x to the first as my variable right here, so when I graph this, it's going to make a line. This is an example of a linear function. So let's graph this one. Remember we said that a function and its inverse are reflections across this line. Look back in your notes. What was the equation of this line? Well, this is the line y equals x. And a function and its inverse are reflections across this line. So if I graph this particular linear function, you remember I'll start here with the y-intercept, and I'll put a point on 0, -4. And then from there, I'll count the slope. You remember the slope is the coefficient of x. So let's write that as 2/1 so that we can see rise and run. So I'm going to go up 2 and right 1. I'll put a dot there right in the center. All right, and I could do that as often as I wanted. Up 2 and right 1. Going over and over and over again until I create a line. So let's connect the dots here. Okay, so the red one here is my linear function, f of x equals 2x minus 4. The blue dotted one, that's the line y equals x. And when I get ready to do the inverse, when I graph the inverse, it's going to be a reflection across this line. So this part should reflect over here, and this part should reflect over here, and they should meet where the function crosses the line y equals x. Remember, because it's on the mirror line, so it should be in the same place. Okay, so let's find the inverse of this one algebraically, and then let's see if it does in fact reflect like we expect it to. So here's my function, the same one I had on the other page, 2x minus 4. And I've got the steps to finding inverses over here. And as we go, I want you to write these steps on your paper so that you have them to refer to as you work on your work in class. So the first thing we're going to do is put y in place of f of x. Now, if you remember from your algebra studies from before, f of x and y are essentially the same thing. It's just that y doesn't necessarily have to be a function, and f of x means this is a function of x. So this one has to be a function. This one doesn't necessarily have to. In this case, it is. And when I replace f of x with y, it doesn't stop being a function. It's just that I'm no longer emphasizing the fact that it is a function. All right, let's see what the next step is. Swap the y and the x. So I'm going to switch out the variables x and y. So where I have a y, I'm going to put an x. And where I have an x, I'm going to put a y. I'm not solving anything. I'm not moving anything. I'm just swapping the position of the x and the y. All right, next step. Solve this new equation that we have for y. So I'm trying to get y by itself, just like you have been doing for the last several years so that you can graph. So let's see what we need to do in this particular case to get y by itself. Well, first thing I'm going to need to do is move this one. So I'm going to add 4 to both sides. All right, and those are not like terms, so I'll just write them both down. All right, and now I'm going to divide by 2. So there's a couple different ways that I can do this division. I'm going to do it both ways so that you can see it. In this particular one, it's going to be easier for me if I divide each thing by 2 separately because I want to graph. So I want my y-intercept and my slope separate from one another. So I'm going to have 1/2 x, because you remember there's that understood 1 right there, and 4 divided by 2 is 2. Okay, so I have completed step 3. I have solved for y. And then my last step, replace the y that I have with f inverse x. You remember this -1 right here above the f? That's not really an exponent necessarily. It's just to inform us that this one is going to be the inverse as opposed to this one that's just plain old f, that's the original function. So I'm going to replace y with f to the -1 of x, f inverse x equals 1/2 x plus 2. So here is my original function, 2x minus 4, and here is its inverse, 1/2 x plus 2. All right, let's graph those and see what we've got. So I'll write it up here. F inverse x equals 1/2 x plus 2. Okay, let's graph that. So I'm going to put first a point on the y-intercept of positive 2. Okay, so far good, because I had a point on my original function at x, where the x-intercept was at 2, and now I'm going to have the y-intercept at 2. So that is a reflection across the line y equals x, just like it should be. The x and the y values have swapped. All right, now let's count the slope from there. So I'm going to count up 1 and to the right 2. So notice this is going up by 2s, right? So when I go up 1 and right 2, I'm going up to 3 right here in between the 2 and the 4 and going over. That's going to be right here. And I could do that same thing again if I wanted to, up 1 and over 2. And fortunately, that puts us right on the line y equals x, because remember we said that those should cross each other on the line y equals x, because that's my mirror line. All right, now look at this one. On the y-axis, my original y-intercept was -4, and that means that my x-intercept should now be -4, because remember, those are going to swap places. I'm going to swap my x and my y. So my x-intercept was at 2. Now my y-intercept is at 2. My y-intercept was at -4, so my x-intercept should be at -4. And if you connect those, you will see that this original function, f of x, and then here's its reflection, f inverse x. This part reflected down here just like we expected. They crossed on the line y equals x just like we expected. And then this part reflected over here, again, just as we expected. Okay, now remember also we said that a function and its inverse undo one another. So if you look at my original function, I took any value of x that I wanted to plug in, I multiplied it by 2, and then I subtracted 4, and I got some other value for the answer. So for example, if I put 1 in right here for x, 2 times 1 is 2, 2 minus 4 is -2. My y value that would match with the x value of 1 is -2. So my inverse should undo that. I should be able to take that value of -2, and I should be able to turn it back into 1. So if I put -2 right here, 1/2 of -2 is -1. -1 plus 2 is +1. So it worked. All right, let's look at what that looks like in function notation. So this means I'm going to take the function f inverse x, which is the inverse over here, and I'm going to substitute it into function f in place of x. So we did one like this before. The 2 and the -4 are going to stay, but the x is going to change. So I've got 2 times 1/2 x plus 2. Okay, let's do order of operations on this and simplify it. So I need to distribute that 2 into the parentheses. 2 times 1/2 is 1. Oops, and I forgot to write my -4 on there. Let me add my -4. And then right here, I have like terms. +4 and -4 cancel each other out. 1x is the same thing as x. So it worked. Whatever happened to x, my inverse undid it, and I turned it back into x. And it doesn't matter which order I do that. In this case, I put f inverse into f. So now let's do it the other way. Let's put f into f inverse. So this time, I'm going to replace this x. I'm going to leave the 1/2. I'm going to leave the +2, but I'm going to replace the x with this. So I've got 1/2, and in place of that x, I'm going to put 2x minus 4, and this time I'm going to remember I've got this +2 over here. So you can see the 1/2 is here, the +2 is here. The only thing that changed is that my x, instead of being x, it became this. It became 2x minus 4 because that's what I substituted in. All right, let's distribute the 1/2 right here. 1/2 of 2 is 1. 1/2 of 4 is 2. And then order of operations, right here I've got -2 plus 2. That cancels out. And 1x is the same thing as x. So again, My function undid itself. When I did both of those, I turned back into the original x that I had. All right, let's do a couple more where we just practice finding the inverse. Okay, so let's look at the steps. Step 1, put y in place of f of x. So I'll put in my y right there. All right, step 2, swap the x and the y variables. So remember, I'm just going to switch the places of those. All right, step 3, solve for y. Okay, now this one looks a little bit more complicated because it's got a fraction there, but the process is the same. The first thing that needs to move is this one. So I'm going to subtract 2 from both sides. Okay, so now let's analyze this 1/3 y right here. 1/3 y is the same thing as y divided by 3. I could write it like that, right? 1/3 of y and y divided by 3 is the same thing. And the opposite of divided by, the inverse of divided by is multiply. So basically, I'm going to multiply both sides by 3. And I'm going to distribute that 3 over there. 1/3 and 3 are inverses. They cancel one another out. That's the multiplicative inverse is what we call that. And I get y by itself, which is what my directions said to do, solve for y. So now I will replace y with f inverse x. So last step, f inverse x equals 3x minus 6. So the inverse of 1/3 x plus 2 is 3x minus 6. All right, let's do another one with a fraction so we can practice that. All right, step 1, put y in place of f of x. All right, so let's do it. That doesn't change anything else, just swapping out the f of x. All right, step 2, swap the x and the y. So again, I'm just rewriting right here. I'm not actually solving anything at this point. All right, step 3, let's get y by itself. Let's solve for y. So I'm going to subtract 1 on both sides. All right, I think I'm going to do this one in 2 steps because there's not a 1 up on top like there was before. First thing I'm going to do is multiply both sides times 5 because I got a divided by 5 right here. The inverse of divided by is times. So I'll distribute that 5. And then remember I said there were 2 ways to do this one. Last time I divided both things by the number that was in front of the y. This time I'm going to do it all in one step. Oops. So I'm going to have 5x minus 5 over negative 3. And I'm running out of space, so I'm going to go ahead and put that f inverse in there just because I'm at the end of the page. So there's my inverse. 5x minus 5 over negative 3 is the inverse of my original function, negative 3/5 x plus 1. All right, one more. Let's try this one. So same series of steps. First, we're going to put y in there. All right, now I want to swap my x and my y. All right, next step, I want to solve for y and get y by itself. So this time the whole thing is divided by 2, so my first step is going to be multiply. A little bit different than what we did last time because it's written differently. All right, now I need to add 3 to both sides. Oh, that plus didn't turn out very nicely. So 2x plus 3 equals y. And then my last step, replace y with f inverse x. So f inverse x equals 2x plus 3, which makes sense. Right here I divided by 2 and I subtracted 3. So the inverse of that, I ought to be adding 3 and multiplying by 2. I did the inverse of both of those operations. And because there was no simplification, you can see it a little bit more easily in this one.